This is the third session of the serverless training with me, Ali Ezedkasti, as you requested. In this session, you'll get more familiar with the digital group of servos. Stay with me. Alright, in the previous comprehensive lesson, we successfully got familiar with a standard server drive, and I meticulously explained its various different parts to you in detail. We explicitly stated that the most critically important and fundamental part of a standard server drive is indeed the CN1 section, and we also thoroughly explained the diverse and distinct parts that constitute CN1. We specifically mentioned that one of the particularly important and crucial components of CN1 is the digital inputs, which are directly related to this specific part of the CN1 terminal. Today, we want to delve deeper and get much more intimately familiar with these essential digital inputs and collectively learn together how to effectively and precisely configure them for optimal performance and functionality. As you can clearly see in this detailed image, these specific numbers that are prominently displayed here are directly related to the CN1 terminal. These particular pins are designated as the digital inputs within the standard servo system. We have the capability to assign a distinct and specific function to each and every one of these individual inputs, allowing for versatile control and operation. In this image, you can clearly observe the various operational parameters of the servo system. Each and every one of these specific parameters inherently possesses a comprehensive set of functions that are meticulously defined within its structure. For instance, if your objective is to effectively assign one of your servo's available digital inputs to activate the crucial servo on function, you would specifically need to navigate to parameter P2-20 and then proceed to carefully set its very first digit. Alternatively, for example, if you intend to assign either the clockwise CW or counterclockwise CCW rotation commands to the digital inputs of your servo, you must first access parameter P2-01, which is located within the broader category of servo parameters. The fourth digit of parameter P2-01 is directly and specifically related to the CW limit setting. Therefore, if you access parameter P2-01 and then meticulously set the value of this particular digit, to which you have the flexibility to assign a numerical value ranging from 1 to 10, depending entirely on the specific number you choose to set here, you can then successfully assign one of the servo's available digital inputs to control the CW limit function. Or, considering another practical example, for an emergency stop scenario, suppose you wish to assign one of the servo's digital inputs to trigger the emergency stop function. In such a critical case, you would first need to enter parameter P2-02 and then carefully set its second digit, and based precisely on the specific value you meticulously set here, you will be able to effectively assign one of the digital inputs to initiate the emergency stop. Alright, here we also enter the servo device and first turn the servo on. We want to see, first of all, how we can access the various and diverse parameters of the servo. So first, we'll learn how to effectively change the different parameters. Here you clearly see 4 distinct buttons. To enter the parameters, we simply press the mode button. Each and every time you press the mode button, the parameters change for us, allowing us to navigate through them. For example, suppose you specifically want to enter parameter P220. After you see P220 displayed, press button 3 once. Now, we have successfully entered parameter P220, and we can then proceed to change the values of those specific digits we previously mentioned. If you press the mode button again, you will then exit the P220 parameter setting. So as we mentioned, parameter P220 is used to meticulously set the various functions for the servo for multi-speed 1, for multi-speed 2, and for multi-speed 3. So if we carefully navigate into parameter P220 and precisely set its first digit, which can be accurately assigned a specific value ranging from 1 all the way up to 10, strictly according to the comprehensive table you clearly see presented here. If we then proceed to set the first digit of parameter P220 to the value of 1, then the designated terminal 47 will be specifically assigned to the servon function. Conversely, if we meticulously set the first digit of P220 to the value of 2, again, strictly according to this detailed table, then terminal 23, originating from our available digital inputs, will be precisely assigned to the servon function. Similarly, if, for instance, we thoughtfully set its first digit to A, which in hexadecimal notation represents the numerical value of 10, then the specific terminal 48, also originating from our digital inputs, will be accurately assigned to the servon function. The exact same logical principle and application applies consistently to the other subsequent digits within the parameter. For example, the second digit specifically relates to the multi-speed 1 function. For this particular digit, we are also able to set a distinct value ranging from 1 to 10. If we set it to 1, then terminal 47 will be specifically assigned to the multi-speed 1 function. If, for example, we set it to 5, then terminal 17 will be precisely assigned to the multi-speed 1 function. In this comprehensive and flexible manner, we can accurately and efficiently enter various specific values as they are precisely needed into these respective digits, thereby configuring the system according to operational requirements. Now, let's carefully go through a few illustrative examples together. Here, for instance, we've precisely gone into parameter P220 and meticulously set its first digit to 1. The first digit specifically relates to the servon, and according to the comprehensive table, 1 directly corresponds to terminal 47, so in effect, we've successfully assigned input 47 to the servon. Now, in this subsequent example, we've deliberately set the second digit of parameter P220 to 2. The second digit is specifically designated for multi-speed 1, and 2, according to the detailed table, precisely corresponds to terminal 23. So we've effectively assigned input 23 of our servon to multi-speed 1. Finally, here we've carefully set the third digit to A. The third digit is exclusively for multi-speed 2, and A in hexadecimal notation is equivalent to 10, which directly corresponds to terminal 48. So we can confidently say that we've successfully assigned digital input 48 of our servon to multi-speed 2. In precisely the same manner, we can meticulously configure the other parameters as well. Now let's proceed to go into the actual device and practically perform the exact same steps we've just thoroughly discussed. Here, we've successfully entered parameter P220. If we press the 3 button once, we will then enter the P220 settings. As we previously mentioned earlier, the first digit is specifically for the servon, which can be precisely set from 1 to 10. The second digit is specifically designated for multi-speed 1. The third digit is for multi-speed 2. And finally, the fourth digit is for multi-speed 3. Each and every one of these digits can be accurately set between 1 and 10. For example, let's say we wish to change the current value of digit 1, which is specifically for the servon. Using the UP button you clearly see here, if we press the UP button, the numerical value of this particular digit will steadily increase. Suppose we want to set the value to A, so we carefully set it to A here. To ensure that this is properly set and permanently saved, we must firmly hold down the set button for a few crucial seconds. We hold the set button for a few seconds so that this parameter is securely saved. In precisely the same way, we can meticulously configure the other digits as well. For example, digit 2, which is specifically for multi-speed 1. If we want to move to the second digit, we can use the mode button to shift the digit one place to the left. As you saw, the second digit is for multi-speed 1, which we can assign a value from 1 to 10. As we mentioned, if we set it to 1, it corresponds to terminal 47. If we set it to 2, it corresponds to digital input terminal 23. Now here, using the UP button, we can increase its value. Suppose, for example, we set it to 3. That means we've assigned terminal 22, our digital input 22, to multi-speed 1. And to save it, we must hold down the 3 button for a few seconds. Now this value is saved for us. In the same way, we can also configure digits 3 and 4. Finally, after we've set all 4 digits of parameter P2.2.0, we can exit its settings by pressing the mode button once. Here, it's showing us a comprehensive table. This particular table is conveniently located in the manual for standard servos, which actually makes our job considerably easier. Well, here it explicitly states that parameter P220, as we have thoroughly explained earlier, its very first digit is directly related to servo on, and you can assign any desired value you want for the first digit of parameter P223. In fact, you can precisely configure servo on. If you set the first digit to 1, terminal 47 will be specifically set to servo on. If you set its value to 2, our digital input 23 will be designated as servo on. Similarly, for example, if you set its value to A, our digital input 48 will be accurately assigned to servo on. The second digit is directly related to multi-speed 1, which again, you can set any appropriate value from 1 to 10 for it. For example, if we set its value to 7, our digital input 20 will be assigned to multi-speed 1. If we don't want to utilize multi-speed 1 at all, we can simply set its value to 0. Similarly, for parameter P201, we observe that its first digit is now directly related to alarm reset. Again, we can set the first digit to any suitable value from 1 to 10. For example, if we set the value to 5 here, it precisely means our digital input 17 will be assigned to alarm reset, and so on. We can also configure the rest of the parameters, and these are related to parameters P2-03 and P2-04. According to this table, we can assign our inputs to any of the functions listed here. All right, the next crucial part of today's comprehensive lesson is specifically about configuring the intricate logic for our various digital inputs. This detailed image here clearly shows us the precise locations and functions of these digital inputs. For each and every one of these individual digital inputs, we have the capability to meticulously define a specific logic. For example, we can very precisely set digital input 48 to operate as normally open, exactly according to what you can clearly observe and understand here in this diagram. If we indeed set digital input 48 to operate as normally open, meaning its fundamental logic is established as normally open, then whenever we connect a standard 24-volt voltage to this particular terminal, strictly according to this illustrated circuit diagram, this specific terminal will then be immediately and effectively activated. Based on the predefined functions that we have carefully assigned, terminal 48 will subsequently perform a very specific and predetermined task for us. For instance, let us suppose we set the logic for terminal 18 as normally closed. In this particular case, under normal operating conditions, a consistent 24-volt voltage must be continuously connected to this specific terminal. The precise moment we intentionally disconnect the 24-volt voltage, the critical emergency stop function that we have previously and carefully assigned to terminal 18 will be instantly and effectively activated. So, in summary, for each of these distinct digital inputs, we possess the ability to assign a unique and vital function, and in addition to merely assigning a function, we also critically need to define a specific logic for it, whether it should operate as normally open or as normally closed. According to this comprehensive table, we can systematically define the logic for all the digital inputs. Here, we explicitly state that if we access and enter parameter P2-08, its very first digit directly corresponds to terminal 47. So we can precisely set the logic for digital input 47 using the first digit of parameter P2-08. If we set its value to 1, it will be configured as normally open, and if we set it to 0, it will operate as normally closed. Similarly, we can meticulously define the logic for our other various inputs. For example, if we access and enter parameter P2-09 and then carefully set its first digit, we can effectively define the logic for input 46. Or, for another instance, if we access and enter parameter P2-09-5, we can then precisely define the logic for digital input 48. If it's set to 1, it's normally open. If it's set to 0, it's normally closed. In this systematic and detailed way, we can thoroughly configure all 10 digital inputs exactly according to the specifications provided in this comprehensive table. Now, let's proceed to go into the device together and practically see how to set these essential parameters directly within the silo itself. As we previously mentioned, let's now enter parameter P2-08. To meticulously enter parameter P2-08, we carefully utilize the up button. With this essential button, we can precisely increase the individual digits one by one, moving through the numerical sequence. We must continuously press and hold this particular button until our desired digit ultimately reaches the value of 8. Here we can clearly observe the display showing P208. If we then press the set button just once with a deliberate action, we will successfully enter into the specific parameter P2-08. As was comprehensively explained in the detailed table presented earlier, each and every one of these distinct digits corresponds directly to one of our available digital inputs, and we possess the capability to set them either to a value of 0 or to a value of 1. For instance, here on the display, it's clearly showing us the fourth digit, which specifically corresponds to digital input 18. Here, for another instance, it's prominently showing us the fifth one, which is exclusively designated for digital input 48. For each of these individual settings, as was thoroughly explained in the comprehensive table, we have the flexibility to set the logic either to 0 or to 1, depending on our operational requirements. After carefully setting the desired value, if we then press the set button just once, we can effectively save this newly configured setting. For example, I have meticulously set my very first digit to a value of 0. Here, it is absolutely crucial that you hold the set button firmly for a few seconds, allowing the system sufficient time to properly save the setting for us. In precisely the same manner, we can proceed to enter the subsequent parameter P2-09. Using the up button, we systematically increase the digit by one increment, and by pressing the set button once, we successfully enter into parameter P2-09. Here as well, within this parameter, we possess the ability to change the value of each individual digit, and for each of these specific digits you clearly see displayed here, we can confidently set the value either to 0 or to 1. If we set it to 1, it will then operate in the normally open state, meaning the circuit is open under normal conditions, and if we set it to 0, it will then operate in the normally closed state, meaning the circuit is closed under normal conditions. So, to reiterate, we can precisely set the value for each and every one of these distinct digits. And after carefully setting the value, it is imperative that we hold the set button firmly for a few seconds so that the value we have meticulously set is properly and securely saved within the system. Hold the set button for a few seconds to ensure it is completely saved, And if we wish to exit this particular configuration, we can simply press the Mode button once to smoothly exit this specific setting and return to the previous menu. And here finally, we have both successfully assigned specific functions to the digital inputs and meticulously set their operational logic. Now, according to the precise wiring configuration we have carefully connected here, you can effectively utilize your digital inputs for their intended purposes. Thank you very much for your kind attention.